Alright, geometry, we are going to work through lesson 27, triangle congruency proofs. Just like lesson 28, it's all proofs. We're going to go through 6 proofs through this viewing. It's going to be a bit long, but I need you to try to focus in and follow the thought process for each one. It actually will be to your benefit to try a few on your own, and then check your answers or check my thought process. Okay, I've already marked what's given and what's reflexive, because remember, if two triangles share a side, then the sides are congruent. So we have given AB is congruent or is equal to AC, RB is equal to RC, and then I marked AR is equal to AR because they both share a side. So I have side, side, side there. So I can say these two triangles are congruent. I have triangle ABR is congruent to triangle ACR because of side, side, side. Now, let's review what we're trying to get to here. I'm trying to say that BS is congruent to CS. I can do that if I can get the whole triangles equal to each other, which shouldn't be too bad. Let's go ahead and say that AS is equal to AS. We've already said AR is equal to AR, but I need AS equal to AS because that's a part of the bigger triangle. So I have these equal, these two bigger sides equal. If I can get an angle equal, then I can say those bigger triangles equal. Well, when we said the little triangles are equal, we can use CP/CTC for these two angles up there. That would be angle SAB. Let's rewrite that. Is equal to the angle of SAC. Congruent parts of congruent triangles are congruent. So if I know those two are equal, then I can now say the bigger triangles are equal. ABS is congruent to triangle ACS because of side angle side. So now SB is equal to SC. Congruent parts of congruent triangles are congruent. All right, I marked what's congruent here also. So let's see, we have square ABCS, and square is congruent to square EFGS. Okay, we also know that these two sides are congruent because they share a side. We're trying to get to triangle ASR is congruent to triangle, let's see if I can change the color, ESR, right? Let's see what else we know here. These are squares, so I know that the corners, oh, I didn't mean to do that. The corners are right, which this corner is right also, which I can transfer to this side through a few statements. So now I know I have two right triangles, and it looks like here's my hypotenuse, and here's my leg. So all I really need to say is that these triangles are right triangles. So let's go ahead and do it. Get my black pen back out. All right, let's start. So we know that they're squares. We know that let's see, AS, so let's just say that these two sides are congruent. Our reasoning for AS equals ES. You know how we can say CP/CTC for triangles, corresponding parts of congruent triangles are congruent? We can actually say that for squares too. Corresponding parts of congruent squares are congruent. That's sort of fun. Let's erase this so we don't get confused. So we know those are congruent. Okay, let's go for angle SAB equals angle SEF equals 90 degrees. Definition of square. Now let's transfer that to the other side of the line. Angle SAR is equal to angle SER is equal to 90 degrees. And this is that really interesting. When two angles, you guys have to remember this one. I've introduced it a few times in a proof, but it wasn't actually in our lessons. Two angles that are supplementary and, I don't know where the and was, and congruent to each other. So two angles that are supplementary and congruent to each other are congruent. And in this case, 90 degrees, because 90 plus 90 is 180. Okay? Now let's say that they are right triangles. Because if an angle is 90 degrees, then you can say they are right triangles. Definition of right triangle. So I've got the two triangles, they're both right triangles. Here's the hypotenuse, and there's the leg. Hypotenuse, leg. Cool? Now I can say that they are congruent. What letters did I use? I think SAR. SER, because of hypotenuse leg. Let's show you. So we're done. All right, let's try another one. I've already marked what's congruent. We can talk through it real quick. I have JK is equal to JL and JX is equal to JY. I'm trying to prove that KX, wrong thing. KX is congruent to LY. It looks like I have two isosceles triangles here. The big one, which is JKL, and the smaller one, which is JXY. Okay, we know that with isosceles triangles, if I have congruent sides, the base angles are congruent too. If I have congruent sides, the base angles are congruent. Okay, let's see. I think I can actually prove that these small triangles are congruent to each other. Okay, I have two sides equal to two sides. Let's see if I can get some angles equal to some angles. Unfortunately, knowing that angle K and angle L is congruent to each other does not help, because that is side-side angle, which isn't a congruence theorem, side-side angle. I really need this angle right here. That would give me angle, angle, side. Angle, angle, side. What's cool is I know these two angles are congruent. And they're supplementary. So I can get that these two angles are congruent. Okay, so let's do that. Angle, I need to say those are congruent. Angle X, JXY is equal to, the measure of, is equal to the measure of JYX. Okay, base angles of an isosceles are congruent. Okay, now let's do that supplementary thing. So we have the measure of angle JXY plus the measure of angle JXK equals 180, the measure of angle JYX plus the measure of angle JYL equals 180. Linear pair are supplementary. Cool. Now I think I know some things are congruent, so I can substitute, right? Okay, let's actually take that. If both of these are equal to 180, I can set them equal to each other. JXY plus JXK equals okay, that's substitution. Cool. I think I have some things equal. Nope. Go back up here. I know that these are congruent. JXY and JYX, right? So I can substitute those in for that side. I just want the same thing on each side of the equal sign, so I can subtract them. The measure of angle JXY plus the measure of angle JXK equals the measure of angle JXY, they're now equal, plus the measure of angle JYL. These two are now equal because I substituted. So that would be substitution again. And I need a new slide. Okay, if you see, that's where we ended up last slide. We just substituted what was equal. Now I'm going to go ahead and subtract those out. So now that they're equal, I can subtract them from both sides of the equal sign. A little bit of algebra in my geometry. Measure of angle JXK is equal to the measure of angle JYL because of the subtraction. Let's write that so you can actually read it. So that is right here, JXK. JXK is equal to JYL. So now I can say those triangles are congruent. Triangle JXK is congruent to triangle JYL because of side angle angle. Cool. Now I've got the base. KX is equal to YL because of CPCTC. Wow. Good job. Okay, number 4. We have 4, 5, and 6 left to go. Halfway done. Here's what's given. I've marked it on the triangle. AD is congruent to AB. And these two lines are perpendicular and those two lines are perpendicular. So let's go ahead and call those some right triangles, because to use the fact that they're a right triangle, we have to say that they are a right triangle. And then I think we can use hypotenuse leg if you look at that really close. ADR and, triangle ADR and triangle ABR are right triangles. And that's because the definition of right triangles. When you have a triangle with 190-degree angle, it is a right triangle. Okay, and I forgot to mark when two triangles share a side, those sides are congruent. So AR is equal to AR because it is reflexive. So now I can say that triangle ADR is congruent to triangle ABR because of hypotenuse leg. Sweet. Okay, let's go back to see what exactly am I trying to prove. Angle DCR, let's not do that. There we go. Angle DCR congruent to angle BCR. Cool. Let's see how I can do that. So to say those angles are congruent, I probably need to prove that the big triangles are congruent that I'm highlighting here. Okay, and I know the two big triangles share this side, and now that I've proven the little triangles are congruent, I can actually say that this angle is congruent to that angle. So if I can do, oh, side angle side, there it is. Side, I have to say those angles are congruent, and then side, I have to say those sides are congruent. Side, angle, side. And side angle side is a congruence property. All right, let's get to that big side. So we have AC is equal to AC because it's reflexive. And angle DAC, the measure, is equal to the measure of angle BAC because congruent parts of congruent triangles are congruent. Sweet. So now we have side angle side. So triangle DAC is congruent to triangle BAC because of side angle side. And now I can say angle DCR, measure of angle DCR is equal to the measure of angle BCR because of congruent parts of congruent triangles are congruent. Not awful. Next. Okay, number 5. I've marked what's congruent. I'm not sure what I need to prove, so let's look at it. BX congruent to CY. So I'm trying to prove that this little side is equal to this little side. All right, let's see, what do I know? Well, I see an isosceles triangle in the middle. Okay, right here. Which means that this little angle is congruent to this little angle because they're the base angles of an isosceles triangle. Not sure if that helps me though. What else do I know? I see two right triangles because I have perpendicular lines, but I don't have a leg. Like I have a hypotenuse, but no leg. So let's see. Ooh, let me get a different color. If I can say these big angles are congruent because they're linear pairs, and linear pairs are supplementary, and two angles are congruent, their supplementary angles are congruent. I'm just looking at, let me highlight it real quick and then I'll take it out. I think I can do these triangles because I would have side angle side. Side angle side. Side angle side. Right? Let me see if that can help me. So if I can say those are congruent, then I can say these little angles are congruent. I should use a different color. Running out of colors. Here we are, orange. I'll say those are congruent because of CPCTC. Ooh, and these would also be 90. I can transfer that over there, and then I would have side angle angle, side angle angle, side angle angle, and then I would have congruent parts of congruent triangles are congruent. Okay, that's a long one. Stick with me and see if we can get there. That was a lot of talking, wasn't it? I'm gonna see if I can erase all this. Nope. Okay, I'm gonna have to rewind. All right, I wrote all over that and I couldn't erase it, so I had to copy it and start over. Okay, so try to stick with me on this one. I've already have what is given. I need to, remember I said that these base angles are congruent because I have an isosceles triangle, so let's name that. Angle, excuse me, the measure of angle ARS is equal to the measure of angle ASR, because base angles of an isosceles are equal. I forgot to write given up here. Cool. Now, if you remember, I guess I could mark them one at a time here. So we just said that. And now I'm going to go for those supplementary angles, and I need these big ones. So let's do that next. The measure of angle ARS plus the measure of angle ARB. I'm on the left side is 180, and the measure of angle ASR plus the measure of angle ASC equals 180. And that is because linear pairs are supplementary. Now, because we know that, let me get my red pen out, that these are equal, I can say that these are equal, right? Measure of angle ARB is equal to the measure of angle ASC. Substitution works. All right, so now I'm going for side angle side, side angle side. So I've got my big triangles congruent, right? Let me erase that so it isn't so crazy. Let's just go ahead and name it. Triangle, excuse me, triangle ARB is congruent to triangle ASC because of side angle side. Cool. And if you remember right, because we said that, we can go for these little angles. Hold on. These little angles are congruent because of CPCTC. Oops, I don't want a highlighter. So angle ABR, the measure of, is equal to the measure of angle ACS, because congruent parts of congruent triangles are congruent. All right, so now I think I need to start a new slide and start talking about the right angles right over here. Okay? Okay, if you remember right, we just finished saying that these two angles are congruent because of CPCTC. Now I need to start going to this being a right angle, and therefore this being a right angle. Okay, so let's head there. The measure of angle, let's name it right, RXB, and the measure of angle SYC is 90 degrees. Okay, it was given that those were perpendicular lines, so we can say that angle is 90 degrees because the definition of perpendicular lines. And now I'm on side angle angle. I think I'm almost out of colors here. So this is 90, this is 90. I can say I've got angle, angle, side, angle, angle, side. I don't think, nope, I can't use hypotenuse leg, so I have to use angle, angle, side. So now let's name those little triangles. Triangle BRX is congruent to triangle SYC because of angle, angle, side. And now we've got those two little sides that we were looking for. Congruent because congruent parts of congruent triangles are congruent. And you did it. Okay, we're almost done. Don't give up on this one. It's a little more complicated. I'm going to try to break it down for you though, so give me a sec. Okay, let's try to talk through this. I've written down what's given, I've marked what's given, and now let's see what we're trying to prove. Right here it says NY congruent to NM. That's what we're going for. NY, NM. How are we going to do it? Okay, if I look at this little triangle right here and this little triangle right here, it looks like I could easily prove them congruent because I have side and then angle, angle. Let's see, change colors. These two little angles are congruent because they're vertical, and that will give me these little triangles congruent to each other. It really doesn't help me with those two little sides. Let's see how I can get to those two little sides. Okay, after I prove those red triangles are congruent, I need to try to transfer all my information down to the bigger triangles. I'm going to do some segment addition, some CPCT scene, and we'll see if we can get there. Let's just follow along this time. Get my black pen out. All right, so this is where we are right now. Let's do those vertical angles, the ones I did in blue. The measure of angle BXM is equal to the measure of angle AXY because they're vertical. And now I can say that triangle BXM is congruent to triangle AXY because of, what did I have? Angle, angle, side. Cool. Now, like I said, I'd like this segment equal to that segment. So I need to add these segments together and add those segments together and then prove that those are congruent. BX plus XY equals BY, and AX plus XM equals AM. And those are both just segment addition. I think some of you have used partition, which works. Now, because of that, we do know that XM is equal to XY, CPCTC, because those are part of those original little triangles. Therefore, BY is equal to AM because of substitution. So right now I have BY is equal to AM. Cool. Now, if I can get, I need another color, purple. I need to get that these, oh sorry, pen. These angles are congruent. Let's see, that one. And this one. Actually, I'm looking for this angle and this angle. Okay, this is going to be hard to see. I'm really trying to prove AMN, with this being my right angle. This side I just proved congruent to the other side. And let's see if I can draw it. BYN. It's hard when down here they overlap. So let's see if that helped you see it any better. And this would be my right angle here. And we just did that this side is equal to that side. So I have to get those angles congruent to each other. And then AY isn't on there. I need another side. BN isn't on there. That one is, that's what I'm trying to go for. Oh, sorry. I know that these angles are congruent to each other because of CPCTC, so I have to say that too. Okay, and I'm out of space, so I'm gonna have to cut and paste this to the next one. All right, I have a little extra stuff here, so don't worry about this and that. Okay, like I said, we need to talk about the angles first, the ones that are in purple. So we do know that the measure of angle BYN is 90 degrees because they're perpendicular lines. And then I need to get to that other one. I need to look back to the givens. Okay, so AMN, the measure of angle AMN is also 90 degrees because the definition, yikes, what was that? Definition of perpendicular lines. So the measure of angle BYN is equal to the measure of angle AMN. Substitution, they're both equal to 90, so they're equal to each other. BYN, AMN, yes. And now I have angle XBM. Let's call it XBN. Is equal to the measure of angle MAN. CPCTC. So I just did, these are congruent because of CPCTC. These are congruent because they're both 90 degrees, and these are congruent because we've already done that. So I'm done. Angle BYN is congruent to, triangle AMN because of angle, side, angle. And now we've got it. That little side is equal to that little side. Because it's the base. So I got the base of YN is equal to MN. I'll show you in a second. There we go. So YN is equal to MN. YN is equal to MN because this is the base of this triangle and this is the base of that triangle. Phew. That one was rough. YN and M is just double checking that I solved the right part. Good job. Okay, that is it for today. That was a long one.